Okay, combinations, part 2. Using things like the words at most and at least. So student council decides to form a subcommittee of 5 council members to look at how funds raised should be spent on the students of the school. There are 11 council members, 5 of them are males and 6 of them are females. How many different ways can the subcommittee consist of exactly 3 females? So if the subcommittee has 3 females, what else does it have to have on it? So how many people on the subcommittee? 5. So if there's 3 females, that means that there would be 2 males. So again, this is a combination because it doesn't matter what order I pick the 3 girls, they're all on the committee. So I'm picking 3 girls out of how many? 6. So then that would be 6C3. And then I'm picking 2 males out of 5. Okay, and I'll give you a moment to tell me what that'll equal. What do I get?
200.
200. Okay. Question B says at least 3 females. So what does that mean? How many females can I have on the subcommittee?
Like 3, 4, or 5.
Exactly. So I can have 3 females and 2 males, or, so or is my plus sign. Actually, I should put 4. 4 females and 1 male, or 5 females and no males on the subcommittee. So then it would be repeating the first one, so taking, sorry, not 3, 3 females from the 6 times 2 males from the 5. Ors become plus signs. And then choosing 4 females and 1 male, or choosing 5 females and then no males. So who has an answer for me? 281. Okay. And then C is at least 1 female. So at least 1 female means that I can have 1 female, or 2, or 3, or 4, or 5. What's the only condition I haven't thought of? At the very top. What am I missing? 0 females. So it's the only committee, really, that I haven't considered. So there's 2 ways that I could answer this. I could do the 6C1, 5C4, on and on and on. Or what I could look at this is I could look at it as almost being kind of the complement, where I look at the number of committees with no restrictions minus the number of committees with 0 females and 5 males, which will be a lot less steps than having to do the 1, 2, 3, 4, and 5 committees. So the no restrictions is just picking 5 out of all 11. and then the 0 females. So that's picking 0 out of 6 and 5 out of 5. What'd you get? Because there's 462 possible committees using no restrictions, and there's only one way that I can pick all 5 guys. Pick all 5 guys. So when you're looking at these of the at most or at least, also consider that instead of going through all the steps, maybe it's shorter to think of no restrictions minus what we call the complement. Okay? So we go into our standard deck of cards. How many different 5-card hands can be formed containing at least 1 red card? So at least 1 red means 1 red, or 2 red, or 3 red, or 4 red, or 5 red cards. What else could it mean?
Do you have 0 red and
Then no restrictions. So no restrictions minus no red. So what do my no restrictions look like?
C5.
Yes. And then my no red, what would that look like? So that means choosing all black cards. How many black cards do I have to choose from? 26. And I'm picking 5 of them. The other thing that I can think of is that I've got 26 cards, 26 red cards that I'm picking nothing of. But what do you think this is going to equal? It's just 1. There's only one way of not picking a red card. That's to not pick the red card. Okay, so I'll give you a moment to figure that one out. This is a large number, so just so that when you get it, if you're wondering, it's
2,533,150.
right? I'll write it down, right? Okay. So then B is at most 2 kings. So what does that mean?
You have 2 kings, 1 king, or 0.
Right. So 2, 1, and 0. So if I have 2 kings, what else do I have in my hand? 3 other cards. So to abbreviate the other cards, I can do one of 2 things. I could put an O for other, or I could put a K with a line over top. And the K with the line over top is the complement to the king, which is a no king. Okay? Nobody's going to test you on your notation, so use the one that you're going to be better suited at. So then I have 1 king and 4 non-kings, or no kings and 5 non-kings. So 2 kings, what does that look like?
Or C2.
And 3 other cards? $48C3. And I get plus 4C1, and now it'd be 48C4. And then the last one, I don't even need to do the 4C0, I can just do the 48C5. What do you get? And your hint is that the number is actually bigger than the last one. What did you get, Rachel?
2,594,400.
Good. Okay, and then we have the last one, 2 pairs. So exactly 2 pairs means I'd have the first pair, and then I'd have the second pair. Oops. And then I'd have one other card. And these are ands, so they should be being multiplied, sorry. 1 pair and the second pair and one other. So how do I pick the first pair? How many do I need for a pair? 2. So I'm picking 2 out of how many? So think about if I wanted to pick 2 5s, how many 5s do I have to choose from? 4. So it would be 4C2 to get my 2 pairs. And it would be the same thing to get my second pair. I'm picking 2 out of the 4. And then I have my one other card out of how many?
Is it 48?
Not 48.
Just subtract.
I have to subtract the other 4. So it'd be 44. Because I'd start off with the 52, I take out these 4, then I have to take out these 4. That leaves me with 44 for my other card. We have one last thing to consider. I need to figure out the values of the pair. Whether or not I get 5s and 6s or jacks and 2s, what those are. So that's picking 2 values out of 13. Because there's 13 cards in each suit. So I need to pick 2 of those cards out of those 13 and then match them up. Okay, so your questions are 1, 2, and 4 to start with. So I'll give you probably about 10 or 15 minutes and then I'll continue on. Okay, combinations which are equivalent. Fran and Bernie have identical collections of vintage toy vehicles. Fran selects 2 of the toys from the 10 shown for display in her cabinet. Since the order of the display does not matter to her, she calculates that this can be done in 10C2 or in 45 different ways. Bernie takes 8 toys to show in his cabinet. Since the order doesn't matter, he gets 10C8, which is also 45 different ways. So the question is, why is 10C8 equal to 10C2?
Well, if you think about it, if you pick 8 to take, you're picking 2 to not take. So it's like the same
Two to
thing.
take, you're picking 8 to not take.
Exactly.
Backwards.
So if you pick 8, it leaves 2, which is the same as picking 2 and leaving 8. Slightly abbreviated it, but it's the same thing. Good. Algebraically, let's show it. So 10C2, according to our formula, is equal to n factorial, which is 10 factorial, divided by n minus r, so it's 10 minus 2. 8 factorial times r factorial, which is 2. And now if we do 10C8, it's n factorial, which is 10. 10 minus 8, which is times r factorial, which is 8.
Yeah,
Because we were really confused.
And order doesn't matter when I'm multiplying them. 2 times 8 won't matter as 8 times 2. So give me another example of an equivalent combination. So probably the best thing is if I gave you one. What would be equivalent to 12C3? 12C9. Okay, try to work on this last one. Algebraically show that NCR equals NCN minus R. Okay, so NCR is n factorial over n minus r factorial r factorial. The NCN minus r is n factorial. And then it's n minus r, which becomes n minus r factorial times r factorial. Well, this one right here, n, if I remove the brackets, I get n minus n, which is 0. And then the minus negative r becomes a positive r. So this simplifies to n factorial, r factorial, n minus r factorial, which is the same thing. We can solve for n in combination problems the same way as we solve them in our permutation problems. So we have a Pee-wee hockey tryout. Pee-wees are 12, 11, and 12-year-olds. All the players meet on the ice after the last practice and they shake hands with each other. How many players attended if there were 300 handshakes? So does order matter? No, because it doesn't matter if I shake Evan's hand before Rachel's hand as long as I shake both their hands. That's the whole idea, is everybody shook hands once with everybody else. So that's what makes it a combination. I don't know how many people they are. That's my n. But how many people do I need to make a handshake?
2.
2. So I'm choosing 2 at a time. And that equals 300. So now I use my formula. N factorial over n minus 2 factorial, 2 factorial. Write that over. 2 factorial. 2. So to get rid of the dividing by 2, I'm going to multiply by 2. So my 300 will become 600. And then my n factorial, I can expand it to be n times n minus 1 times n minus 2 factorial. So it cancels out with the n minus 2 factorial on the bottom. And then I remove those brackets, n squared minus n. Bring the 300 over. And now I need to find two numbers that when I multiply them together, I get 300, and when I add them together, I get negative 1.
This is L, isn't it? Minus 600.
Yes, sorry. So two numbers that when I multiply together, I get negative 600. Add them, I get negative 1. Which one's positive, which one's negative?
Negative 20.
Yes.
Positive 24.
So then what can n equal?
25 or -24.
Okay. Do both of these answers make sense? No. Can't have negative 24 players. So there were 25 players. How else could I solve this? What were the other two ways we talked about with the permutation question? You just start guessing? I could just start guessing. Looking at it logically, if I have a hockey tryout implies that I've got more players than I need for a team. So I can think of a larger number to start with. I could even just start with 20, go up from there. The other way I could do this is I could put it into my table. So I could let y1 equal NCR, and then I could look at my table of values and see where I hit 300. So those are a couple of other ways that are non-algebraic. Okay, this next part, sometimes there's a question that comes up on the diploma that has to do with diagonals. So it says, consider a circle with 5 points on the circumference. How many triangles can be formed using these 5 points? Answer in combination notation. So how many points do I need to draw a triangle? 3. So I'm choosing 3 points. And how many points do I have to choose from? 5. So how many ways? 10. Okay. Then I have how many lines can be drawn connecting 2 points on the circle? So 5C2, which equals? The same as 5C3. Why is it the same as 5C3? 5 minus 3 is 2. Okay. Sketch a regular pentagon. What does regular mean? Pentagon would be a 5-sided figure, and regular would mean that those 5 sides are all equal. So you're going to sketch or try your best to sketch a regular pentagon. We show that it's regular by
I was kidding.
the tick marks.
You're not kidding.
Just trying to figure it out.
No, I do know that.
Okay. Now suppose I had these points.
Expect us to leave it on the surface.
How many lines can be drawn connecting connecting the 2 points on the pentagon, including the sides of the pentagon. So it's basically the same as this question. Because if I join these points, I'm going to get my pentagon shape. So what was the answer to that one? 10. Because I have 5 points, and I'm picking 2 of them. So I have 10 possible lines that I can draw. Let's look at them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? I should go down here. How many of those were the diagonals of the pentagon? 5. Because I started off with 10, but then I can take the 5 outside lines off, and that gave me 5 of them. In combination, or in terms of combinations, this is the same as taking my, my 5C2 and then subtracting the 5 outside lines. So suppose I had an octagon. How many sides in an octagon?
Oh, 8.
8.
I didn't.
So the number of diagonals in an octagon, 8C2, would give me the total number of lines that I can draw. To get the diagonals, what do I need to remove from this? I have to take the 8 outside lines off. $20? So if I had an n-sided polygon, to figure out the diagonals, would be NC2, the number of sides of the polygon, picking 2 at a time, and then removing the outside lines. That would leave me with just the diagonals. So the last question. You're given the number of diagonals it has. A polygon has 65 diagonals. How many sides does it have? So this is my NC2 minus n has to equal 65. So my NC2, I have to use that factorial notation. N factorial over n minus 2 factorial, 2 factorial. Minus n equals 65. If I work on simplifying this, the n factorial, that becomes that n times n minus 1 times n minus 2 factorial. And 2 factorial I can just write as 2. You know what, I'm going to put the other n on the other side with the 65, just because I think it might make it a little bit simpler for the next part. Now I can cancel this out, my 2 factorial factors. Expand the top, I get n squared minus n. And how do I get rid of the dividing by 2? Multiply by 2. So I multiply this side by 2 and it's gone. When I multiply this side by 2, what do I get?
130 plus 2.
130 and then I bring everything back over to the other side. So I get n squared minus 3n minus 130 equals 0. And now I want to factor that. Multiply to 130, add to negative 3. That would be multiplied to negative 130.
Positive 10, negative 13.
So 10 and 13. So what does n equal?
13.
And the negative 10 gets eliminated because it doesn't make sense. Okay. I could again use my table of values, NCR minus n, and then look at where it equals 65 if I didn't have to do this algebraically. So your questions are number 11 to 15. And I'm going to put in 8 as well. So question number 8 and then 11 to 15.